Welcome back, students. In this video, we will be doing the rest of the algebra review questions. We start with rational equation. As I just mentioned in the class, they are super important. The first step before jumping into solving them would be talking about the forbidden value or restriction, or in other words, NPV value. The NPV value, as a reminder, would be the values which make the denominator of the fractions 0. So here I have this denominator which is consisted of two brackets. So I have to find the values which make it 0. So to find the NPV value would be x plus 7 shouldn't be 0, x minus 12 should not be 0. So from here I could say the two NPV values are negative 7 and 12. From here I can start solving the next step. Remember, I told you one of the most important useful tools in rational equation would be cross multiplication. But before using it, make sure you have the condition. The conditions are satisfied. What was the condition, if you remember? One fraction on either side of the equal sign. So I have one fraction here, one fraction on this side. What I'll do here, I start by doing cross multiplication. So negative 3 by this, 12 by this. Okay, negative 3 times these two brackets. So these two brackets would be x squared, addition of these two numbers times x, and then multiplication of these two would be equal to 12. From here it's a quadratic, but before solving it I will divide both sides by negative 3, and if I divide both sides by negative 3, this side would be negative 4. Okay, so in the next step I will be moving negative 4 to this side of the equation because I want to have all the terms on one side and then equate it to 0 so I can use the formula. After simplification and division, it will turn into x squared minus 5x minus 84 plus 4. After simplification, final simplification, it turns into x squared minus 5x minus 80 equal to 0. So I use the formula to find the roots. The two roots would be negative b plus and minus b squared 25 minus 4 times ac. Then you substitute in the formula. Your two roots would be either 5, these two, which are different from the NPV value. Okay, so here the a would be 1, the b would be negative 5, the c would be negative 80, and then you simply substitute it in the quadratic formula to get the values. And after finding the roots, you have to make sure that they are not equal to the NPV value. Otherwise, we cannot accept them as an answer. Next example would be 93 divided by 21n multiplied by another fraction equals 7. The first thing we have to do, we have to find the restriction or NPVs. Here the two fractions, they have the same variable, so n should not be 0. After identifying the NPV, we can start by simplifying. This is how we can simplify. 93 by 21, divide both sides by 21, and then here that would be n would be n squared. Then you can simplify it with this one. So what is left would be 7n, right? 7n after the cross multiplication, because this one can be even simplified further. So 7n, okay, equals 15 n squared, or you can either simplify the n from here or in the next step. So from here, this one turns into quadratic equation. I rather solve it with factorization. I factorize an n times 15n minus 7 equal to 0. From here, I have to find the roots. One root, as you can see, is 0. The other one is 7/15. We are not done yet. We have to check the values of the root against the NPV. As you can see, the 0 cannot be accepted. So the only acceptable answer for this rational equation is 7/50. Okay, next equation would be two big fractions multiplied by one another equals to 1/5. So first step would be defining the restriction or NPV. So p minus 1 should not be 0. P plus 4 cannot be 0. P plus 1 cannot be 0. From all of these, you can say that the NPV values would be -4, -1, and 1. So there are 3 NPV values. -4, -1, and 1. So after you solve the equation, you have to check the final roots against these NPV value and make sure they do not overlap. So let's start this equation by simplifying. Okay, so here what I'll do, I can simplify this, will be simplified by this. Okay, and let's see here, is there anything else I can simplify? I can simplify 25 with this 5. What else? I think that's it. So the next step would be cross multiplication. This is how I do the cross multiplication. Okay, this is 1/5 from the other side. On this side, I'm left with p plus 6. On the denominator, I have 5. I have p minus 1, and I have p plus 1 from here. So I'll do cross multiplication. I end up with 5 times p plus 6 equals 5 times p minus 1 multiplied by p plus 1. As you can remember, this is one of those identity difference of squares, p squared minus 1. From here, two sides, I can divide both sides by 5. Okay, to get rid of the 5, to cancel out the 5. Next step would be moving around everything to one side and finding a, b, c to put it in the quadratic formula. So p squared minus 1. Then I have p plus 6. It will be moved to the other side, but the sign will flip. After simplification, I have this equation. So let's say here the a is 1, b is -1, c is -7. I substitute it in the formula, minus b plus and minus b squared minus 4 times ac. After simplification, we get two roots, p1 and p2. Okay, then we have to check against the NPV values, which were -4, -1, and 1. And none of them overlap. So these two answers will be accepted. Okay, let's do another rational equation. Here I have another two fractions, but they are multiplied and then equal to 3. So first of all, I start by defining the NPV. This fraction and this fraction should not be 0. So the NPV values are -3 and -10, because -10 makes this denominator 0. And -3 makes this denominator 0. So these are the restrictions. They are the non-permissible values. Then I start by a little bit of simplification. Here I will factorize a 10. So I will be left with v plus 3. I have 15 here. And then I have v plus 10 from the denominator of the first fraction. V plus 3 from the denominator of the second fraction. These two will be simplified, and then I have 3 on the other side. So after simplification, I have to do cross multiplication. So 3 times v plus 10 would be 150. And then from here, I can divide both sides by 3 to make it a little bit more simple, working with smaller numbers. So v plus 10 would be equal to 50. From here, the value for v would be 40, which is different from the NPV values. So this is an acceptable answer. Another example would be a constant subtracted from a fraction equals to 1. And we're supposed to solve this one and find the value for x. First step again would be finding the NPV. So this one and this one should not be 0, which gives the value of -4 and 5/7 as the NPV values. Then we can start solving and simplifying. Here, what I suggest, instead of doing common denominator on this side, okay, and dealing with a quadratic, I will move -1 to this side by adding -1 to both sides, and then I add this fraction to both sides. Okay, so I added a little bit of moving around, so 5 would be equal to this fraction, and then the next step, I have one fraction here, one fraction here. Although this is a big fraction, it doesn't matter. I can do cross multiplication. So 5, 6 minus 1 is 5. 5 times these two brackets, 1 equals 1 times x plus 5. Here what I'll do, 5 multiplied by these two brackets. So I just did the multiplication. You can use the FOIL rule. Remember, there is a video. If you don't remember, you can watch the video on the FOIL rule. So 7x multiplied by x, 7x squared, 7x multiplied by 4, 28x, -5 multiplied by x, -5 multiplied by 4 equals to x plus 5. Then I start by simplifying. These are two like terms, so 23x. After a little bit of simplification and moving everything to one side, I end up with having this quadratic equation. As you can see, the coefficient cannot be any further simplified. This is a. I start identifying a, b, c to substitute it in the quadratic formula and find the roots. So a is 35, b is 114, c is -105. I substitute it in the formula and I find the two roots to be these values, which is not a whole number that most of us usually expect, but is still acceptable because they do not overlap with the NPV value. Some more examples. This is one of the examples from the handouts I gave you. Here I have 3x equal 27 over x. So I start by defining the NPV. The only denominator available is x, which shouldn't be 0. So NPV value should not be 0. I start by doing cross multiplication. 3x squared equals 27. Then in the next step, I divide both sides by 3. So x squared would be 9. And from here, I go square root from both sides. But when you're doing a square root, x would be plus and minus the other side. So here you have two roots. One of them is +3. The other one is -3. You check it against the NPV. It's not the same. So both answers are accepted. Another example would be 2x minus 1 equals 3 divided by 2x plus 1 minus 5. So as I just mentioned, start with NPV. X cannot be 0. 2x plus 1 cannot be 0. So the NPV values are 0 and -1/2. In the next step, what I prefer to do, it's up to you how you want to start solving it. You can either do a common denominator between these two on this side and another common denominator between these two on this side and then do cross multiplication. But when I usually have two constant, I try to move them to one side because working with constant and doing operation on them, arithmetic operation is much easier than doing operation on fractions. So what I'll do, I just add 5 to both sides. So this turns into 2 divided by x plus 4 equals, now I do common denominator. So that would be x. And here it will turn into 2 plus 4x. Okay, this is the first side. And on this side, remember, I'm left with this, so I just leave it. So the next few steps would be as follows. So from here, I can do cross multiplication. 3 times x equals, I factorize a 2 from this one. This turn into 2, 1 plus 2x. And this one is also, if I just change the order of the terms, this is also 1 plus 2x. So in other terms, you could say 1 plus 2x to the power 2, and I use one of the identities. It's much easier for me. So 2 multiplied by first term to the power 2 plus 2 times first term multiplied by the second term, and then the last term would be second term to the power 2 equals 3x. From here, I have to move around everything to one side and identify A, B, C. So I can put it in the quadratic formula. So here the A is A, the 8 is A, B is 5, and C is 2. The next step would be simply substituting in the quadratic formula, which is -5 plus or minus 25 minus 4 times AC. But if you look closely under the radical, under the square root, it's a negative number. And as you can remember, if under the square root is a negative number, our quadratic equation would have no real roots. And we stop here. Okay, let's continue with another rational equation. Here I have two fractions, one on either side of the equation. I start by finding the NPV values, which makes the denominator 0. The first value would be 3. The second value would be -5/3. And then for the next step, I will do cross multiplication. So 7 multiplied by 3x plus 5 equals 2 multiplied 2x minus 6. Then I will move around everything, simplify, and the final value of x is -47 divided by 17. I compare it against the NPV value, not the same, so these are the accepted value. Another example would be 6x minus 1 divided by x plus 1 equals x minus 1. NPV, that means this guy should not be 0, so x cannot be -1. There is only one NPV value. Next step would be I'll start by doing cross multiplication. X plus 1, right, multiplied by x minus 1 equals 1 times 6x minus 9. So that would be x plus 1, x minus 1 equals 6x minus 1. This is one of those identity number 3, difference of squares. So x squared, this will be x squared minus 1. Okay, x squared. Then I have 6x on this side. I move it to this side, and I have -1 plus 9 plus 8. Okay, so here I identify A, B, C, and I substitute in a quadratic formula, and the two values of the roots would be 4 and 2. I compare them against the NPV, not the same, so I keep both roots. Let's do another simple rational equation. Here I start by defining NPV. This denominator and this denominator cannot be 0, so x cannot be -1/2 or +1/2. Then I'll do cross multiplication. As you can see, I do cross multiplication and then start by using FOIL rule on both sides, and then moving around all the terms onto one side, equating to 0 and adding the like terms. So after applying the Voigt rule, 6 squared will cancel out. I have 7x here, and on this side I have negative 7x. So here I have 7x, and on this side I have negative 13. So I move everything to one side. That would be 20x. On this side I have plus 2. I move it to the other side. That would be negative 2. Okay, so that would be 3. So the final value for x would be 3 over 20. Although you had like a term which was a square, but because it was cancelled, the final value, the number of roots is only 1. 3 over 20, and it's only 1. Compare it against the NPV, not the same, so this value is accepted. Okay, another rational equation. I have a combination of fractions added or subtracted to one another. Here I don't have any fraction which the denominator is a letter, so there are no NPV values. In other words, there are no restrictions. Okay, because the denominator is either 8 or 3. So I'll start, as I just mentioned, when I have a few constants which can be added or multiplied by one another, I start by simplifying those. So I move this 5 over 8 to the other side. By adding 5 over 8. So this one will be changed into 2 over 3. 7 8 minus 4x equals, this will turn into 8 over 8, which is in other words 1. Now what I can do in order to get rid of the 2 over 3 on both sides, I divide both sides by 2 over 3. Okay, but remember, when you are doing division of fractions, okay, so the first fraction is written multiplied by the reciprocal of the second fraction. Okay, so negative, I have here 7 over 8 minus 4x is equal to 7 over 2. Okay, now what I'll do, I add negative 7 over 8 to both sides. So on this side I have to do a little common denominator. I'll do, and negative 4x would be 5 over 8. So the x would be 5 8, right, divided by negative 4. When I'm doing the division, I will write the first fraction multiplied by the reciprocal of the second fraction. So the final answer is 5 over 32, which is the acceptable answer. Let's start by doing another simple rational equation. A fraction equals 1. Okay, so the NPV value would be negative 3 over 2, because negative 3 over 2 makes this denominator 0. So I'll start by doing cross multiplication. Okay, 2x plus 3 equals to x plus 1. I move around this x. I add negative x to both sides. So that would be 2x minus x, which is x. Then I add negative 3 to both sides, and it turns into negative 2. So this is the final answer. It's different from the NPV, so I keep the answer. Let's do another rational. This is kind of an intermediate one. I start by defining the NPV. So this denominator and this denominator should not be 0. The values which make them 0 are 0 and negative 6 over 5. These are called the restriction. Then on this side, I have to do common denominator. I'll go with x multiplied by 5x plus 6. Okay, this is the common denominator. In order to find the numerator, okay, so this fraction is actually multiplied by this value, right? And comparing this to this one, it's like this fraction is multiplied by x. Okay, the next step would be adding these two fractions which have the same common denominator and simplifying. Okay, and after simplifying I can just do cross multiplication. Okay, after doing cross multiplication I would have 7x times 5x plus 6, which is equal to 3x squared plus 4x plus 6. Okay, now I start by doing the FOID rule or multiplication and moving everything to one side and adding or subtracting the like terms, and at the end I would have this quadratic equation. I will factorize the 2 to make the coefficients smaller, and then I will end up with 2 multiply 16x squared plus 19x minus 3, and then I substitute the value to get the root, which would be negative 19 plus and minus b squared minus 4 times ac, which will be negative 19 plus and minus 481 divided by 32. I don't think we can simplify it any further, so we get two roots which are different from the NPV values, and we will keep both roots. This is another rational equation, one of my favorites, which was already done during the class, but I will bring it here for emphasizing. So here I have one very huge fraction. On the top I call this fraction A, and I call this fraction B, and I call the whole thing C. Okay, so I have to first start by defining the NPV values. If I consider the fraction A 2x negative 4, okay, 2x negative 4 cannot be 0. So this is the first value, the NPV value. Now if I consider fraction B, okay, so this thing should also, the denominator should not be 0. So this is the second NPV value. Now let's consider the bigger fraction, which we called it C, which is A over B. Okay, so if we want the C, right, and if we want to find the restriction for fraction C, that means the B, whatever it is, should not be 0. That means this fraction, which is 3 minus 2x divided by 3 over 2x, should not be 0. If a fraction is 0, that means the numerator is 0. So from here, I would say x should not be 3 over 2. Otherwise, b would be 0, which makes the big fraction, which is c, undefined. Okay, so here the tricky part is that here you have 3 NPV values. After defining the 3 NPV values, you will start by doing some simplification and solving. For the rest of the equation, I will start by, what I'll do, I will start by writing the first equation, the first fraction, which is x1 plus 2x minus 4, and it is divided by another fraction. So if I want to find the answer, I'll keep the first fraction as it is, and then I just multiply it by the inverse of the second fraction. Okay, and on the other side it is equal to -1. So here I will start by multiplying and doing cross multiplication. Okay, so -1 is multiplied by 2x minus 4, 3 minus 2x, and on this side I have x plus 1, okay, multiplied by 3 over 2 multiplied by x. After doing simplification and moving all the terms to one side, I will end up with this quadratic equation. This is A, this is B, this is C. Some of you might prefer to multiply this equation by 2 and get integers at the coefficient, but for this equation it would be easy even to work with 2.5 and 12.5. But as I just mentioned, I prefer to work with integers, so I multiply both sides by 2. 0 by 2 would be still 0, but on the other side it will turn into 5, negative 25 and 24 as my ABC. Then I substitute it in the quadratic formula and I get my values. And as you can see, the final values are different from the NPV, so I keep both of these two values. Another example, this was also done during the class. So I have two fractions added together equal to 0. I start by defining NPV, so x squared minus 1 should not be 0. Then x cannot be positive and negative 1. On the other side, x plus 2 plus x should not be 0 either. So from here I get 0 and negative 1. So the NPV, the set of restrictions would be 0, negative 1 and plus 1. Then I would start by solving the equation. So some of you might start by doing common denominator on one side and then doing cross multiplication, but I personally prefer to start with easy things. So what I'll do, I move around the first fraction to the other side, this fraction to the other side, okay? And then here there would be two fractions, one on each side of the equal sign. So instead of doing common denominator, I'll just start by doing cross multiplication, okay? After doing cross multiplication, then I move everything to one side. I define A, B, C, okay? I define A, B, C. I substitute it in the formula and I get two roots. So one of the roots is 1 over 3, the other one is negative 1. But if you compare the roots against the NPV values, negative 1 wouldn't be accepted because it's the same as the NPV value. Okay, let's finish this video by doing another rational equation. On the first side I have two fractions, on the other side of the equal sign there's only one fraction. So first step would be defining NPV values which make the denominator 0. So t cannot be negative 4 or 4, or even on this side 4 and negative 4 are the answers. So what I'll do here for the next step would be doing common denominator, t plus 4, t minus 4, and these two would be difference of squares, so that would be t squared minus 16. Okay, so keep that in mind. After doing some simplification, okay, instead of doing cross multiplication, what I'll do, I would say I have two fractions which are equal. The denominators are exactly the same, so the numerator must be the same. So 6t minus 16 plus 8 equals to 10. From here I get the value of t to be 3. Then the next step would be comparing it against the NPV value. It's not the same, so I accept this value. I hope you enjoyed this video. Please follow me for more videos on algebra and other topics. Thank you.